Okay, in this video we're going to continue trying to mimic Python 3. We're going to try to write functions that mimic some of the built-in behavior of Python 3. So last time we tried to code up a substring, isSubstring function. It should return true or false, and it takes in one string and it checks to see if that string is a substring of the second string provided as an argument. Okay. So you'll find as you code things, generally speaking, especially the more complicated the thing that you're coding is, usually it takes a few iterations to get something that's very good and very clean and efficient and clear. Okay, so this is a relatively small program. It's not really doing too much, so there's not a whole lot of efficiency gains that we can get, but we can get some clarity in our code here. And clarity is very, very important. The clearer the code is, the more someone else will be able to interact in your code base, and the more you'll be able to interact looking at it in the future, right? So some of these things we might be able to clean up a little bit. What we're working on today is going to be very similar as the isSubstring method. What we're going to look for is what we'll try to build is a find method. So what we're going to do is we're going to take a string and we're going to try to locate a substring in that string, and that instead of returning true or false, we should return the index of where that string is located. Okay, so let's start a new file and we're going to call this find substring.py. Okay, so we're going to define find substring, and it's going to take the same parameters. One thing from last time that I think might have confused some people is my use of short names here, S1 and S2, and then I1 and I2. While these are valid, especially starting out, short names can get a little confusing. So S1 and I1, that sort of thing. Especially down here, it gets a little confusing what's going on. So I'm going to choose to use longer names when we do this. So this is going to be the substring that we're searching for. This is the greater string. Let's see, what should we call this? This is the parent string, because this is containing the substring. Or I guess to keep our nomenclature the same, we might call this the superstring, right? So sub and super. All right, so the superstring is the larger string. The substring is the smaller string inside of the superstring. Okay, so now we got some terminology that will help us identify these items a little bit. So we might call these sup and sub, right? Something like that. But we've got some longer terms that are it's gonna help us identify what these things are. Additionally, this find function is eventually going to optionally take a starting index. So where in the superstring do we want to start looking? Right? So by default, we're going to set this equal to 0. All right, so Python has a syntax available to you to have optional parameters, right? And you can set a default value to it. So since I've set a default value of 0 to this, when someone calls this function, they are not required to provide this argument. I've not set values to these. There's no default. So if you call this function, you are required to provide the two strings. But you can optionally provide a start index. And then you can also optionally provide an end index. Okay? And so we would probably want to set this equal to none, and then the ending index is going to be calculated. We're going to calculate that based on the length of the superstring, right? So you would want to stop searching at the end of the superstring, right? So the ending index. Now we can't say for sure what the end index is right here in this parameter definition, because we don't know. It depends on superstring. And because we're not in the body of the function yet, we don't have access to this variable yet. So we have to change the value of end index somewhere in the body of the function where we can have access to this variable, right? So that has to do with function scope. All right, so we have this function, and what are we planning on returning here, right? So we want to find the index of the first occurrence. All right, so we want to find the index of the first occurrence. Now that index is going to be the starting point. So say we have the superstring is CAT, and then the substring was AT. Okay, now this is just an example. This is an actual code. This would be, we're playing around down here somewhere. We have a superstring cat, and we're looking for the substring at. Okay, so if we start at C, we see what we don't have a match, right? So we move on to the next character, and we iterate through this word until we see that the first character matches. Once we see that the first character matches, we iterate the subroutine. The subroutine is going to iterate over one character at a time at both the substring and the current position of the superstring and check that all the characters match. Okay, so in this case, we detect the match, and then we go one character at a time to compare these two, right? Now, if we do have a match, in the last version, substring, we returned true. In this case, we want to return the location at which the match occurred. So here we have to keep track of the index from this initial iteration as we iterate through this list, or through these the string of characters, right? So in this case, this is index 1 of this string, right? The letter C is index 0, A is index 1, and the match occurs at index 1. So the return value, if this search is successful, is going to be an index number. The index number has to be between the actual values of the superstring, right? It has to be an actual index value, right? We can't go beyond the length of the string, right? And it's going to be an index value. Now, if we don't have a match, what do we return? Because matches are going to be an index value, meaning it could be a 0, right? If the word was attack, for example, we would have a match with at index 0, right? So that's allowed, and we could also have at the end here, like with cat, right? Or it can be somewhere in the middle, like with catch. But either way, the starting location of the match here, in this case, is going to be index 1, right? So if there is no match, so if we have something like house, there is no match of AT in this entire word, in this entire string. So in that case, we want to return something else that's not going to make sense in terms of what we're returning. So we could throw an error. There's an option for us to raise an exception to say this wasn't found, and a lot of times that's what Python does. Other languages like JavaScript will return, when you search for a string, it returns -1, because -1 isn't a valid index. That's telling you that it was not found. Okay, and in this way we don't have to deal with catching errors and doing catching exceptions and that sort of thing, right? So we're going to do that. We're going to find the index of the first occurrence, and if none exists, return -1. All right. So that's the main idea here. So let's start, and we can periodically jump back to substring here and see how we did things, and see if we can make our code a little bit more clear in this newer version. This newer version is basically a rewrite of substring, except we also have additional functionality, and we're not returning true and false, but a lot of the code is going to be the same. So we're gonna bounce back and forth and look at this for reference. All right. So we want to find the substring. All right. So here we have to consider the initial cases. Right. So these are the cases in which we can know very, very quickly if our string, if a substring find is even possible. All right. So here, S1 is substring. So what I'm going to do is I pasted this in from the other program, I'm going to copy and paste and make sure I get every single one of these instances of S1 to our new name. We're using a longer name to help us visually see the code a little bit better, right? So there's substring and then superstring. All right. Another thing we might do is it might be cleaner, I discussed a little bit through the last video, it might be cleaner to do something like this, where we return for each individual case. So if the substring is longer than the superstring, then there's no way it can be contained by the superstring. So we'll return -1. We might say if the length of the substring equals 0 or the length of the superstring equals 0, then we'll return -1. Okay, so because we've changed the variable names and separated out that long if, it's a little bit more readable, right? So if length of substring or, oh, here's the issue. So this red dot in Atom tells me when I've got, it's a linting error. So I use PyFlakes and it's integrated with Atom and it tells me when I've got little errors here. So if I press back there, that goes away. My alignment was off by a space. The indentation is incredibly important in Python. All right, so we've got those two easy cases taken care of. So what did we do next here in substring? So we had to have two index values, right? The superstring index, which was I2, we're going to call that SUP_index. Maybe we should just call it P index because sub and sup are really close. So this is P index for super, and that's going to start out at 0, and then we're going to have the B index, the substring index, and that's also going to start out at 0. But there are two main things that are going on, right? As we saw last time, again down here, if you've got the substring, the superstring of catch and the substring th or tch, right? The greater loop, the outer loop, is iterating in the superstring, right? So this is our second string provided in our arguments list, right? This is the superstring parameter, and we are iterating one character at a time over that. So that's the outermost loop. That's the thing we're doing before anything else, right? Only if we have a match here do we go into this second sort of phase, this second subroutine, right? So let's just focus on the outer version first. The outermost loop is just iterating over each character of the superstring, okay? So we had a while loop as well. If we can pop back in here and we see this while loop. Now this is another spot that's a little bit tricky to read. So we explained what was going on there with this, but let's just copy this and paste this so we can look at it up here, and let's see if we can find a little bit easier way to represent this equation. All right. So the idea here, first of all, I2 is our P index. That's our super string index. So P index. And then S2 is our superstring. Okay. And then S1 is our substring plus 1. Okay, so what is this saying? All right, if we have our example here, we have catch and we have TCH. Okay, so I want a while loop that's going to run, and this is the outermost while loop. So I want this to be true. So while my superstring index is less than the length of the superstring, right? And this is all one expression. Let's go ahead and put this in parentheses. In Python and computer science in general, expressions evaluate all the way down to one single value. So sometimes it's helpful to add parentheses to help clarify which things are getting evaluated first. Now there is an order of operations, and Python will automatically abide by those rules, but in case it's unclear to you, the author, you can always look it up, but sometimes it's best to just add parentheses to be very, very clear and explicit about which thing's being evaluated first. So in this case, this whole thing is one expression, all right? And order of operations dictates in subtraction and addition, it's just in order. So we start with this function call. This function call is evaluated. This is also considered an expression all by itself. It's a very simple expression. You execute the length function, pass in the argument data, and you'll return a result. So at that point, it's been evaluated. So here we have an evaluation. This is the length of the superstring. And then we want to subtract the length of the substring, but then we want to add one more. So down here, we're going to go over that. Why is that? Okay. So we're searching, P index starts at 0, so it starts at index 0. That's this letter here. And to get rid of that red dot, I'm going to add a pass here. And I'm going to pass on this while loop while I explain. Okay, P index, the superstring index, starts at 0, right? That's this character. And it iterates through. Now we saw last time the length of the substring here is 3. So once I get to here, if this wasn't a match, for example, let's do something, can't think of there. So in this case, this would not be a match, right? If I go one character at a time, I'm going to compare that to the first character. Do we have a match to start checking the rest of the characters? No. Does that character match the first character? No. Does this character match the first character? No. Now technically, after this no, so the index is 0, 1, and 2. At this no, I no longer have to check the rest of these because the remainder of the string is smaller than the entire substring. Okay, so it's the length of the whole string, the superstring, minus the length of the substring. So that's going to be 5 minus 3, but that puts us at 2, which would be this character. We still do need to check that character, right? Which is why we add that 1 at the end. Okay, if we didn't add the 1 at the end, we wouldn't be checking this character, right? So this is basically the expression that tells us how far into the superstring do we need to even search. Okay, so that was for checking to see if something exists. It's checking to see if the substring exists in the superstring. Okay, we're doing something a little bit different. We want to find the index. Okay, and that's fine. We're going to have the index stored. Here we've got both the superstring index, which is what we're going to return, and then B index. Right, that's the substring index. All right, and did we do this? Somewhere in here we should have set the substring index back to 0. Right here. So if there was a match false, we should have actually set this back to 0. If we would have done a little bit more testing, we would have seen that. So the second string, as we iterate through the two strings, comparing them one character at a time, if we find out we don't have a match, then we need to set the substring index back to 0 so we can start the comparisons again for the next potential match. All right, so really technically, apologize for that. I'm just realizing that that wasn't in there. Here we need to have, this is going to be the substring index, so that's going to be S1, that's going to be I1. You're going to set that back to 0 if you find out that there's not a match. Otherwise, we'll get some false positives. And generally speaking, when you have a function like this, you're going to want to think a lot about the different tests, and you want to have an exhaustive set of tests to try all the different possibilities. The video was getting a little bit long last time, so didn't quite finish all of the different tests that we should have done. And as we see, there was a small issue here. So this would have caused a problem in something like this. So say we had apps and apples. So this whole string. So we would have a potential match here, right? The first character matches, and then the second character matches. So we'd be incrementing I1 as we do these comparisons, right? But here we find that the S and the P don't match, and so we find that the match is a false, right? And if I don't reset that first index to 0, then I'm going to start the compare at the last letter anytime I find a first character match again. Okay, so this would cause us issues. So here, I believe we would find a character match, but then this would be false because I1 would be wrong, which would give this a match false, and so we would never detect that this successfully matched app. All right, so we can test that real quick. All right, so I will leave this off. I'm going to comment out that one addition that I made, and we can run this. This is Python 3 substring. Okay, so let's see. It did find that match. Let's see, why would that be? Plus. Oh, so it did find the match, but it didn't actually compare it. So it's checking here. We're adding what I1 was, which was already advanced. It was not 0. So it would, right, it would successfully find this, but then it would not work on something like this. The first character would match, the second one wouldn't, but then it would only check the last one. So this should be true. Sorry about that. It keeps the screen resolution keeps changing. All right, so this one should be true because of our error here, I think, if my calculations are correct. Right, so this one is true, even though app does not exist in this. Right, and so this stresses, this example stresses the importance of being very thorough with your tests, because we thought we had it last time, and this is, obviously my fault, but the video was getting long, so I wanted to sort of cut it off. But you have to be very thorough. So this is a good chance to explain sort of the process of computer science. And a lot of times you'll have situations like these where you'll find an edge case that you never encountered before, and then all of a sudden you have to make a fix to one of your functions. But to make sure nothing else breaks, you have all of your previous tests. And all of your previous tests should also still work, and then the new test should work. Okay, this is pretty standard in professional development. All right, so we kind of glossed over that last time, and we saw the consequence of that. All right, so with the fix, right, this one should not be true because app is not in here. So let's add the fix. And sure enough, that one turned false. None of the others changed. True, true, false, false, true, false. True, true, false, false, true, false. Okay, so we added one additional test case, and we added one line, and that line was important. Okay, so back to what we have going over here. We're finding, and in this case, if we go back to substring, we're just going to return the index of our superstring, which here is called I2. Okay, so I'm going to try to move away from this, but I might have to check back and forth just to make sure we're doing something similar that we did in the last one. There's lots of different ways to code things, so I want to try to stick to this working model already so we don't confuse things further. All right, so this is what I want my while loop to do, right? Unless the end index provided up here is shorter than this, right? So this is the calculated index of where we should stop, right? We were searching this is the superstring, this is the big string, right? We're searching one character at a time, searching for that first character match, and if we find the first character match, then we start another subroutine of comparing both of those together. Now, in this case, we don't detect a match, and at this point we know we can stop, right? Because there aren't enough characters left. All right, so that's the maximum end length, right? So here, this is really maximum end length. So I can call that. I can have a variable called max max end length, and this is going to be equal to this expression. So I can copy that and paste it and save it in this variable. So this is the maximum end length, right? Put this up here. All right. So what expression do I want here? Well, I want to use whichever is, if I wasn't provided an index, an ending index, then I want to use the max end length. So this is the ending index, right? So basically, if end index equals none, because it defaults to the value of none, and it's only none if the user doesn't provide a value here. All right. So if that's none, then I'm going to change the value end index. Instead of calling this max end length, I'm going to call this the end index, right? And we're going to indent this. So here we're changing the value. This is basically saying if the user did not provide an ending index, then our ending index, we're going to calculate it based on our superstring and our substring. However, if they did provide the index, if end index does not equal none, if it equals a number, right, then we're going to keep end index because that's when we want to stop. And actually, this entire thing is a Boolean value, right? What I actually want, I want this p index down here in the while loop. So what we were comparing before, this was actually the ending index, right? It's the length of the superstring, so 5, minus the length of the substring, so that's 5 minus 3, so that's 2, right? So 0, 1, 2, and then plus 1, right? So we want that one more. And as long as our superstring index, so remember our superstring index is the one iterating over the larger string. This is our outermost loop. As long as that index is less than this, we want the loop to run. Now, unless they specified the index themselves, right? And if they specified the index themselves, then we can just place that in here. End index. Okay, so we've simplified this a little bit using longer names for variables, and we've actually added complexity, but right now it's a little bit, it looks a little bit easier to read, and we have a better understanding with this idea of an ending index. Previously, our while loop Boolean expression here was a little bit hard to read. This is easier. This is saying the p index should just keep iterating over our superstring until it reaches some predefined ending index. Now we can either calculate that, or that can come from up here, right? We could also add some sort of protection to say if end index that the user provided is greater than the calculated one, then we'll use the calculated one, right? We're going to assume that's not going to happen because that adds extra complexity. But somebody could potentially add like an ending index of 2000, right? And that might cause a problem because this while loop is going to keep going until p index is less than 2000, right? So that's not good. So we would probably want to protect against that. Maybe we should go ahead and protect against that. Let's do that. All right. So in that case, that would be if the end index the current end index is less than, this is the calculated maximum end index, right? So maybe we want to put this in a variable now since we're using it twice. So generally speaking, you don't want to make a calculation 2 different times. We made this calculation once, right? This is the calculated maximum index, right? So let's call that max end index. And we're going to copy this. And we do this calculation one time at the top. And now here we're going to replace this with the variable holding what we already calculated, max end index. All right. So now since this is already calculated, we can use it again. So if the end index, that would be if the user provides an end index, we know it's not none because we set it here if it is none. So if end index is less than the maximum end index, and if we set it here, this is going to be false, right? Because we know if we set the value to maximum index, then max end index cannot possibly be less than max end index, right? So this is automatically false if they did not provide the ending index. But if they did provide it and their ending index is, actually this should be greater than, right? If their ending index is greater than what we've calculated to be the maximum, then we're going to set this end index back to the maximum. Otherwise, we're going to get an error. Okay, so I can just duplicate this line and move that down. Okay, because both of these if statements have the same body, right? We could technically say if this is true or this is true. And we could join them together like that. Now there's nothing wrong with this, but the more Boolean expressions you add together, it can get harder to read. So oftentimes it's recommended, especially starting out or in Python, to stick to multiple if statements, being more explicit. All right, so we'll go back to this way, and I'm just hitting Control-Z to undo what I did. So here we have the 2 separate if statements. If the ending index is none, meaning they didn't provide one, then we calculate the ending index. And if they did provide an ending index, or we set it ourselves, and that ending index is greater than the maximum, then we go ahead and set it back down to the maximum so we don't have any issues. Okay? So this might be a position where a comment might be useful. So if the user does not provide an ending index, this is if the user does supply an ending index, but it's bigger than the max, then we set it back to the max. Okay, so these are where comments can be useful, especially when you start getting into algorithms and things that have a little bit more complexity. Now I know this is actually a really simple thing that we're doing, looking for substrings, but the complexity as far as telling the computer what to do, it can be a little daunting. So especially starting out, use comments and make sure they're clear. Now one important note about comments: whenever you have a comment, you must maintain that comment. Okay? So here, this comment is kind of stale. It doesn't mean anything anymore, right? Because the maximum end index, this is the calculation. So this isn't a good comment anymore. I need to explain what this line is. So this is the maximum index in which the outer loop should test for a substring. Okay, so with any kind of comments you add, whenever you modify that code, always check the comment too, because if it changes what the comment means, then that's a bad comment. Bad comments should always reflect current code. If you change the code, you need to change the comment. All right. So we have our index values. We have our outer loop. This is much easier to understand now, while p index is less than the ending index. So while our superstring index, iterating one character at a time over our superstring, is less than end index, we're going to keep going through this loop. So this is the the substring first character. So the substring first character. We are constantly going to be looking in this while loop one character at a time for this substring first character, that T. We are looking for that because once we see that, that initiates the subroutine in which we compare T and then H, or C and then H. Right? So in this case, if we have a match on that first character, that's when we do the subroutine. So that's the inner loop. If I switch over to the substring file, that's going to be this inner loop that we did here. Okay, so we do that if there's this match. All right, so let's implement that. So we first have to get the first character of our substring. So here, this is the first character of the substring is just the item at index 0. So this is our B is, again, remember, that's B for substring. And then the P stuff is P for superstring. So P index is the superstring index, and B index is substring index. All right, so B first character. All right, now we can dig into this loop. We can say if B first character is equal to, in the superstring, the item at P index. So we're starting at one character at a time, but we want to get this character in our superstring. So this is going to be sup with a P, super string, and the item at the superstring index. So if that first character of the substring is equal to the current superstring character, that's when we initiate our subroutine. Okay, so essentially our subroutine here is this. All right, so the match portion is just a way to let us know if we have a match. And then we would return, instead of true here, we want to return the index value where the match occurred. Right? So this is saying while our substring is index is less than the length of our substring. So that's a common sort of while loop expression. While some index, that's our substring, so that's the B index, is less than the length of our substring. Right? While that's the case, we want to compare these characters. Okay, so we can say if the superstring character, so it might be clearer if we explicitly define these characters as separate variables, and this is optional, right? As you code, you'll develop different strategies about when to create new variables and when not to. Sometimes it's a good idea to create a variable just to add the label that the variable provides. So in this case, we're going to say the P character, this is the superstring character, is superstring located at the superstring index right? So here we were iterating through catch, and here's our first match. So our P character that we're trying to get is the item at the superstring P index, but we also have to add the B index, because as we progress through B, we also need to progress here, right? So if our B index is at 0, 1, 2, then we should be starting from our P index here and then adding 0, 1, 2 as well to compare the H to the H. Okay, so this must be P index plus B index. All right, so that is our super character. And then our substring character, so the B is for sub, right? This is substring B index. Okay, up here I put P index twice. Take a second, and if you're coding this up yourself, take a second, and it is important that we change that. All right, P index and B index. Okay. So attention to detail, very easily your programs can be wrong by one character. If I would have left that, the program would have failed, right? So that attention to detail is very important. And I'm sort of wishing now I had more distinct names than superstring and substring because they're so similar. But we already picked it, so we're going to stick with it. So anyway, this is another example of why naming is important, because it can be confusing. P index and B index are awfully close, right? So here, the P character, which is the superstring character, and B character, the substring character. And each one of these will change each time through the loop if we increment our B index somewhere down here, right? So we're going to check to see if there is a match. So if the P character is equal to the B character, oops, then that means so far it's a match. So that means we're going to increment B index and keep going through the loop. So B index plus equals 1. All right, that's if we do have a match. Otherwise, we don't have a match. And if we don't have a match, this entire subroutine can stop. Right? So in the case of we have T here, bath. Baths. We have to do baths because 3 characters. So we get to this T, right? And that is a potential match. So we enter this subroutine. And then we go to the H, and that is on the substring a C. So this is not a match. That's what we're checking here. Does the P character, the superstring character, equal the substring character? If that is not a match, then that's this else statement. And if that's not a match, we don't need to keep comparing. I don't need to compare the S to the H. It's just not necessary. So I can break out of the loop and stop this subroutine calculation. All right? Now that brings us to this loop eventually finishing. Once B index becomes equal to the length of the substring, we've gone too far and the loop has stopped. All right, so at this point, let's go back to one that is a match. Okay, so this should return 0, 1, 2. The match occurs at index 2. So that's the starting point of the match. That's what we're trying to return. Okay, so as we iterated through this loop, if we had a match, then we need to return the index. But if we didn't have a match, then we need to continue through the outer loop. Okay, so we have to do the thing we did before, which is where we added this match flag. Match equals true. And we always assume there is a match unless we determine that there isn't a match. Right? And the reason we do this is because in this while loop, it's a match only if you get all the way through the while loop. However, if we ever get to this else statement, that's the one time we know for sure that we don't have a match. Right? So this makes the most sense to set it up as always a match and then set it to false if we determine there's not one. Because it's harder each time through the loop to check to see if we do have a match, right? You have to have some way of determining if we don't have a match, right, specifically. So that's why we set it to true to begin with, and then we set it to false when we don't have a match. But this depends specifically on this implementation and this particular problem. Sometimes in different cases you might start it with false, and then there's one case in which you would set it to true. It depends what you're looking for, right? But in this case, this makes the most sense. So match equals false, right? And then we also have to remember, as we went through in the substring, in this else case, we have to set our substring index back to its initial value, back to its initial 0, because we were using it to, iterate through each one of these when we were doing the comparison. So we gotta set that back. Spell this right, false. And then b index, we're going to set that back equal to 0. And this is if we do not have a match, right? But if we do have a match, this loop will eventually end without ever triggering this flag to be false. So it should still be true from up here. And then so down here we can say if match, which is essentially saying if match equals true. It's a shorthand way of saying if match is true. So if match, then what do? Well, we want to return where the match occurred. So on all these index values, what is the one that dictates where in the superstring the match occurred? So that is our p index, right? Because we never changed the p index in the subroutine, right? We left it alone because there might not be a match and we might have to continue on to the next character, right? The way we incremented this, searching through these characters in the subroutine, is by adding the b index. Okay, so this was never touched. This is still the outermost loop, one character at a time. All right, so this p index, if there's a match, that's what we return. All right. Yeah. So if the first character matches, right? And then eventually this while loop is going to end. And if this while loop ends, we want to return false because it got all the way through everything, or we want to return -1, right? That's the index. That means unsuccessful find. So whenever we return -1, that means we did not find what we were looking for in the string. All right. All right. Is that it? Let's take a look at substring and see if we're missing anything. Oh, I need to increment my in my while loop. At the bottom of my outer while loop, I need to increment our index. All right. So that is the p index. P index is going one character at a time as we iterate over the superstring. So here, and this has to be inside the while loop, right? So one indentation level in. Your text editor should hopefully have the indentation markings. It's very important that it's at the right indentation. It's a totally different thing to add, say, p index plus equals 1. If I were to do this at this indentation level, then I'd have an infinite loop on my hands because p index would never increase, meaning we'd never be going from one character to the next, and this loop would just run forever. Because when it gets down here, there's no code at the proper indentation level, so the loop repeats. So this indentation is absolutely critical. And that has to match the innermost part of the while loop. Okay, so indentation is critical. Alright, so we can save that. And then I think we're good. So let's try some of these. Let's just copy over these examples, and we're going to change, obviously, the name of the function, but these should be returning, instead of true and false, that should return the index. And if it would be a false here, then we should see a -1 in our results. Okay, so this is going to be our test. So instead of calling isSubstring, the name of our function is findSubstring, and this should be returning a number. Right? So something you can do here, if you have a nice text editor, is search and replace. What am I looking for? IsSubstring, right? And what do I want to call it? Let me copy and paste the name of the function here, findSubstring. Okay, and I click here because that's where I want to start the search. Click find, and it gets highlighted, and I click replace, 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 replace. And then it goes back up to here. I said no, that's fine. Actually, that should not say isSubstring. That should just be substring. That was a lucky find. So our program would have broken there. That was a very lucky find. All right, but as I said, very often as you're coding, one character can cause a problem. All right. So we save this, and over here we see this is the last run of substring. It was true, true, false, false, true, false, false. So we should see two numbers, two -1s, a number, and then two -1s. If this is working right, which we'd be pretty lucky to get it going the first try. So Python 3, this is findSubstring. Okay, so none, none, -1, -1, none, -1, -1. Okay, so this is working, except it's not returning. So the false values are working, -1s, but when we have an actual value to return, if there is a match, I forgot to fill out that part. Right, so we don't want to just return none here, so that's why this is none. We want to return the index in which the match occurred. So that is the P index, the superstring index, the outermost index. So P index. All right, we can run this again. And here the match occurs at 6, so that's 0, 1, 2, 3, 4, 5, 6, and sure enough, that character is where the match begins. Here the match begins at 0, which that is correct. That's the 0 index. Here, can't happen, can't happen. Here it's at 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I started counting at 1. That's my fault. 0, 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, A is the 8th index. So the 9th character, the 8th index. All right, and then these other two cannot occur. So these are the other test cases. All right, so now we've added complexity, but because we added complexity, I felt the need to use better naming, right? Naming is very, very important. You do much more reading of code than you do of actually typing out code. So having good names, having good structure, having very readable code is absolutely critical. All right. So think about the names you use and don't be afraid to change them, but make sure if you do change them, we could change superstring to something else, but we have to make sure we change it in every single place and even the comments. Otherwise, it's going to be confusing. All right. So this is a nice example of something that we use all the time in Python, which is like find a string, where's that string located, and we sort of take it for granted. But we see there's actually a fair amount of complexity to it, right? We actually really have to think things through, use diagrams. We had two different superstring, superstring and a substring that we were going back and forth to reference what's happening in the code. So, you know, use drawing on paper or a whiteboard or anything like that to help you as you plan through the code. All right. So hopefully you learned something in this video, and we'll continue with some more mimicking Python in upcoming videos.